Hi guys, welcome back to Practice Lab. In this video, I'm going to discuss interview questions and answers related to microservices. So let's get started with the first interview question. So first interview question is, what are the key benefits of using microservices over a monolithic architecture? So microservices is basically an architectural style where an application is composed of small, independently deployable services. It has many benefits over monolithic architecture. First one is flexibility. It means each microservice can be developed, deployed, and updated independently. Second is scalability. It means microservices allows you to scale individual components based on demand. You can optimize resources and performance. Third is a resilience. It means if one microservice fails, it doesn't bring down the entire application, so helps to improve overall system stability. Next is technology diversity. It means different microservices can be built using different programming languages or frameworks, so it allows you to choose the best tool for each specific task. Last one is faster development cycles. It means smaller focused team can work on different microservices simultaneously, speeding up the development process. Okay. Next question is, what are the main challenges associated with microservices architecture? So first, the main challenge is complexity. Managing multiple independent services, each with its own database or code base, can quickly become overhead as the number of services increase. Next is inter-service communication. Since microservices communicate over a network, ensuring reliable and efficient communication between them can be difficult. So it can lead to a potential latency or failures. Then we have data management. In a microservice architecture, each service might have its own database, so it makes harder to maintain data consistency and manage transaction across services. Then we have deployment and monitoring. With so many services to handle, deploying, monitoring, and troubleshooting can become more complicated. It will be required robust tools and practices. Then finally, there is a security. Each microservice needs to be secured individually, which increases the attack surface. This requires careful management of authentication, authorization, and data protection across all services. The next question is, how do microservices communicate with each other? So microservices communicate with each other in many ways. First one is APIs. So microservices usually communicate through APIs using protocols like HTTP, REST, or gRPC. REST is widely used for its simplicity and ease of integration, while gRPC offers performance advantages and supports bidirectional streaming. Second is message brokers. For asynchronous communication, microservices use message brokers or queues such as RabbitMQ or Kafka. This tools helps handling data and tasks between services without requiring them to interact in real time. Third is service discovery. Microservices often need to find each other dynamically. Service discovery tools like Console or Eureka maintain a registry of services to locate and interact with each other even as instances scale or change. Next is service mesh. To manage and secure communication between services, a service mesh like Istio can be employed. It provides features such as load balancing, security, and observability, helping ensure smooth and secure interactions. And last one is data format. So data exchange between microservices is usually in JSON formats. So JSON is a common due to its readability and compatibility. The next question is, what is the role of an API in microservices? So APIs enable microservices to communicate with each other by providing a standard interface for sending and receiving data. Next is decoupling. It means APIs helps to decouple services, allowing each microservice to operate independently and interact with others through defined interfaces. Then interoperability. It means APIs ensure that different services potentially built with different technologies or languages can work together seamlessly. Then scalability, it means by using APIs, microservices can be scaled up or scaled down individually based on their performance or specific needs without affecting other services. And then security, it means APIs facilitate controlled access and security measures such as authentication and authorization, ensuring that only authorized services or users can interact with microservices. The next question is, what are the key characteristics of a microservice or microservices? So here you can see the list of characteristics of microservices. First one is modularity. It means microservices are designed as small independent modules that handle specific functions or business capabilities. Second is scalability. It means each microservice can be scaled individually based on its demand, enhancing the system's ability to handle variable loads. Third is decentralized data management. It means microservices manage their own databases and data, reducing dependencies and allowing flexible data handling. Fourth is resilience. It means the failure of one microservice does not impact the entire system, improving overall fault tolerance and system reliability. And last one or fifth one is autonomous deployment. It means microservices can be developed, deployed, and updated independently, enabling continuous delivery and faster interaction. Next one is technology agnostic. It means different microservices can be built using different technologies or programming languages, providing flexibility in technology choices. Last one is inter-service communication. It means microservices interact with each other through APIs or messaging systems, which allows them to work together despite being separate entities. Next question is, how does microservices architecture support scalability? Okay, so microservices architecture supports scalability in different ways. First one is individual scaling. It means each microservice can be scaled independently based on its specific load or performance needs rather than scaling the entire application. Then load balancing means microservices architecture enables efficient load balancing, directing traffic to the appropriate service instance to handle varying demands. Then elasticity means the architecture supports dynamic scaling, allowing services to automatically adjust resources based on real-time demand. Then a decentralized management, it means by isolating components, microservices reduce the task or risk of bottlenecks and allows targeted scaling where necessary. Then deployment flexibility, it means services can be deployed on different services or different server or cloud environments, optimizing resource utilization and scaling as needed. The next question is, what is service discovery and why it is important in microservices? So service discovery is the process of automatically detecting and locating microservices within a network. It involves maintaining a registry of services and their locations. It helps for dynamic scaling. It means as services scale up or scale down, service discovery ensures that the updated locations of these instances are available to other services for seamless communication. Fault tolerance means it helps manage service failures by redirecting requests to healthy instances, ensuring continuous availability and reliability. Load balancing means service discovery integrates with load balancers to distribute traffic evenly across available service instances, improving performance and resource utilization. And simplified configuration means it reduces the need for hard-coded service locations, making configurations more flexible and adaptable to changes in the system. The next question is, what is the difference between microservices and traditional service-oriented architecture? That is SOA. So first difference is in service granularity. In microservices, the focus is on small, highly specialized services, each handling a specific business function, whereas in service-oriented architecture, typically involves larger, more generalized services that handle broader business processes. Second difference is in deployment. In microservices, services are deployed independently, allowing for more frequent updates and better scalability. In service-oriented architecture, services are often deployed as a part of larger application, which can make independent updates more challenging. Next difference is in technology stack. So microservices allow different services to use different technologies, languages, and databases, providing flexibility. Whereas in service-oriented architecture, SOA generally relies on consistent technology stack and middleware, which can limit flexibility. Next difference is related to data management. In microservices, each service manages its own data, promoting decentralized data management and reducing dependencies, whereas service-oriented architecture often relies on a shared central database, which can create a data management challenges and dependencies. Next difference is related to communication. So microservices use lightweight protocols like HTTP or REST or messaging queues for communication between services, whereas service-oriented architecture typically uses heavier protocols like SOAP or relies on enterprise service buses for communication. So these are the differences between service-oriented architecture and microservices-based architecture. Next question is, how does microservices architecture handle data management? Microservices architecture handle data management in different ways. First one is decentralized data storage. In this, each microservice manages its own database or data store, reducing dependencies and enabling independent data handling. Second is data ownership. In this, services own their data and enforce their own data consistency rules, which helps maintain separation of concerns and reduces coupling. Third is data replication. In this, services can replicate data across different services as needed, ensuring that each service has access to the necessary information without tight integration. Fourth is APIs for data access. In this, microservices interact with each other through APIs to exchange data, allowing services to query and update each other's data while maintaining the boundaries. And last one is event-driven architecture. In this, data changes are propagated through events or messages, which allows services to stay updated with minimal coupling and ensures eventual consistency. Okay, guys, that's it from this video. If you like this video, please like, share, and subscribe for upcoming videos.